Hello everyone, thank you for joining this session. Today, we will be demonstrating features and benefits of ETAP Power Management System. During this session, we will provide an overview of the ETAP Power System Monitoring and Simulation PSMS solution. We will demonstrate how ETAP PSMS interfaces with typical electrical devices in order to collect live data. Next, we will demonstrate the benefits and some of the applications of using digital twin analysis with live data using the predictive simulation feature. We will also demonstrate how an electrical SCADA can be deployed using the digital twin model. And finally, we will demonstrate our situational intelligence feature, providing unique insights on the state and behavior of the electrical system. ETAP Power System Management leverages the digital twin model to monitor, operate, and simulate for a wide range of mission-critical industries like generation, industrial, transportation, and low-voltage systems. Using the digital twin model, users can create powerful but simplistic HMI views to monitor and operate all electrical assets. It also combines the intelligence of the digital twin simulation to reproduce, diagnose, and analyze events to understand the behavior of the electrical system against real-time or historical operating conditions. Features like situational intelligence provide operators with high-level insights of the response of the electrical system before any operator action. First, let's take a look on how ETAP PSMS solution interfaces with electrical devices and enterprise systems, bringing the system from design to operation. One of the major advantages of working with ETAP is continuous evolution of the electrical model, allowing the continuous life of the electrical model from design to operation. It all starts with the electrical model. Based on the intelligence invested in creating the digital twin, we will leverage the model to deploy different types of solutions for monitoring and operation. Now with the model online, optimization tools like situational intelligence and predictive simulation are used to better understand the online response of the electrical system and get feedback on how to improve the electrical model. These valuable insights will help to develop a far better understanding on the electrical operation, every time with better understanding of the behavior of the electrical system. Now, in the next sections, we will take a look on how we can start to get live data into the digital twin. The first part of moving from design to operation is understanding how ETAP PSMS will interface with electrical devices to obtain live data. On a typical site, regardless of the industry, there are typical electrical devices that provide live measurements. Examples of these are protection relays, power quality meters, power meters, RTU, just to mention a few. In order to interface with these devices, we will add a data collection server. This data collection server uses the existing infrastructure on the facility to interface with electrical devices. Our ETAP data collection server is capable of handling many of the common communication protocols for electrical devices, such as IEC 61850, Modbus, DMP3, etc. Once ETAP PSMS can establish communication to the devices, we can bring the digital twin model online. ETAP will read critical measurements such as power flows, voltage, currents, etc., and also critical indicators such as trips, changes in status, alarms, etc. At this point, engineers can start using the digital twin model to run simulations using live data. Additionally, ETAP PSMS can interface not only with electrical devices, but also other data sources to read critical data for the electrical operation. Examples of these are process SCADA, DCS, etc. Next, from the digital twin model, you can deploy very simple but powerful HMI displays to monitor the system. Additionally, operator displays can be deployed to securely operate the system. Note that the PSMS is hardware independent, so ETAP can communicate to any manufacturer regardless of the brand. ETAP PSMS solution can be scaled to an enterprise solution. Earlier, we demonstrated a simple version to deploy the system. However, this is a solution that can be scaled to fit complete enterprise solutions. The robust client-server architecture enables deployment and support for multiple clients, from clients located in dedicated workstations to secure web clients that can monitor data from the web or mobile devices. Scalable and modular design allows application servers to be deployed in separate machines for large enterprise systems. Also, scalability allows to expand features with the site needs. For example, a facility can start with just an operator HMI, but later on can add other features like operator training simulator or eProtect solution. High availability allows continuous support for a continuous operation of the system in the event of a contingency, either single site or through multiple sites. With the integration of secured managed access, administrators can restrict unauthorized access and limit user roles and actions, all in order to create secure access portals for users to monitor their data. Portable visualization also allows users to visualize the digital twin and analysis modules on a secure platform either hosted on-site or on the cloud. ETAP includes powerful tools to help you interface electrical devices to your digital twin. On the ETAP model, we start by identifying points where live measurements are available. In this example, we indicate the electrical model that at this location we have a device that can provide online measurements like power, status indicators, alarms, etc. The ETAP SCADA Integrator tool allows you to create building blocks called device model to define typical measurements for a device. You can link the device model to all ETAP components sharing the same typical measurements. Using this type of integration, it reduces the amount of time spent on integration. The ETAP SCADA integrator now has a cross-reference between an electrical component modeled on ETAP to an actual physical device providing live measurements. In this demo, we can observe the electrical model is now reflecting the areas where live measurements are available. This is the same model that was used for power system analysis. The difference that on this model, we have included all metering components to reference where live measurements are available. Every component is also modeled to a voltage and current source to better represent the power flow. On the SCADA Integrator tool, we can see every component listed here. Additionally, in the device model section, you can see all the building blocks for all the typical devices used across the site. For example, on this demo, I have listed all the protection relays, power quality meters, RTUs that can provide data. We can see that for this typical relay, I have added all power measurements, breaker status, and relay alarms. Each device model is linked to all the components in the electrical model using the same characteristics. Once an ETAP component is linked to a device model, then the ETAP SCADA integrator will dynamically create tags. This workflow makes the process of integration very simple and fast because every component is linked to a live measurement already modeled on the digital twin. Now, after the database is complete, we can now go online. In this section, we will take a look on validating the digital twin and also predicting system response using predictive simulation feature. ETAP PSMS will increase the visibility by leveraging online data and the digital twin in order to create pseudo measurements to estimate the power flow across the rest of the model, including areas where metering is not possible. Additionally, the ETAP PSMS will validate monitored data versus the electrical model. This is one of the advantages of using a digital twin solution. This will bring to light any discrepancies between the digital twin model against operating conditions. This will also validate the quality of all measurements using an electrical perspective. In this demo, we can see the electrical model now displaying data from all electrical devices with live measurements. Now, since we have live data and an electrical model with nominal data, impedances, ratings, typical loading, etc., ETAP PSMS can predict the power flow across the rest of the model. These new measurements, displayed in red, indicate the estimated power flow where metering is not possible. The state and load estimation feature will predict these measurements across the model. Additionally, the electrical validation tool allows to validate live measurements versus the electrical model. This helps to bring to light any discrepancies, for example, issues where the model component does not reflect the as-built or the operating ratings, creating a deviation between the predictive power flow. This will also help to continuously keep the electrical model up to date to reflect the as-operating conditions. In predictive simulation, you can also evaluate the behavior and response given different conditions. Let's take a look at 3 common scenarios where you can use online simulation in the areas of operation, planning, and switching changes. In operations, we can evaluate the changes of taking a critical circuit breaker out of service and see how it affects relay coordination. For planning, we can evaluate what is the effect of increasing the load. This could be because of operations requires sudden increase of loads to a substation due to changes in the process or there are changes in the electrical process. Another scenario is evaluating the effects of switching sequences. This could be switching from a servicing bus from A to B or taking a circuit breaker out of service. We would like to evaluate how this is going to impact arc flash values. With the predictive simulation running with online data, ETAP takes a live snapshot of online conditions such as circuit breaker status, operating load and generation, bus voltages, and other measurements to the analytical engine. Then, users can take this online snapshot to create changes with the digital twin. This is now where users can create scenarios for changes with online conditions to run the simulation. Finally, users can evaluate the result of the simulation and take action. Based on the predictive simulation, users can determine if the action may cause an undesired behavior on the system. Predictive simulations are available on any of the ETAP simulation modules using either real-time data or historical data. Next, I will make a demonstration on how real-time data can be used on predictive simulation. In ETAP, we create side-by-side views showing online presentation and a simulation presentation. Note that you can run any simulation module using ETAP real-time data or historical data. In this demo, we have one line view on the left side and a simulation on the right side. In this demo, we can also evaluate what is the effect of suddenly taking a generator out of service. Next, I will go ahead and open the circuit breaker of the generator and run a load flow simulation. We can observe that taking this action will cause alarms. As you can see from the alarms, the transformer XT2 will be overloaded. On another demo, we can evaluate the sudden increase on the amount of a load due to changes in the operation. For this, I will enter the new value and run the simulation. As you can see, increasing the load at this location is also going to create additional events. In this case, it will overload transformer XT1. On another demo, we can run a transient stability study case to observe how does it affect coordination on breakers. On this scenario, using live condition, we will simulate the trip of a circuit breaker of a tied circuit breaker after 100 milliseconds. As you can see, this also causes to trip circuit breaker 2A1 because of an overcurrent. Last, on this demo, we can observe the changes of doing a switching sequence. In this demo, we're taking down a transformer for maintenance using real-time conditions. Then we evaluate each step and observe any alarms generated. From this simulation, we can see that this action causes multiple overloads on the system. In addition to the electrical validation and predictive simulation features, ETAP PSMS includes visualization tools for operators. ETAP includes native tools that allow to convert ETAP model to an HMI page. This is a great tool to save time building HMIs. One major advantage is the drastic reduction of the number of animations and calculation tags required. From ETAP, you can export your model and quickly create HMI tools. This will help to reduce the time invested on animations required to display the correct color for energization. By using the ETAP model, the ETAP HMI engine uses the same switching device continuity coloring just like ETAP. Therefore, if an element is energized in ETAP, it will also show energized in the ETAP HMI. In addition, user-defined custom summary views for monitoring can be generated. These are particularly useful if you want to have detailed views for specific electrical components. In addition, user-defined custom summary views for monitoring can be generated. These are particularly useful if you want to have detailed views for specific electrical components. In this example, we can see how you can create a dedicated pop-up for an equipment and include additional critical data from the system such as phase measurements, alarm, critical alerts from the equipment. The ETAP HMI viewer includes powerful visualization and analysis tools. HMI clients are supported either as a standalone or web HMI clients. Alarm and notifications in case an event is detected, or measurements operating outside of a normal range. Custom reports can also provide additional operational data. For example, you can use the reports to evaluate the energy usage per operating process in an electrical system to evaluate their efficiency. Similarly, trends can be used to view changes over time of critical measurements, for example, changes on the power factor over the main lines to evaluate the operation efficiency. In this demo, we can see the HMI standalone client displaying summary views. In addition, navigation bars are implemented to make easy to find any page. Web HMI clients provide the same portability using HTML5. Also, any alarms or event processed by the ETAP PSMS server are also visible to the clients either standalone or web. User report features allows to create quick reports to visualize past behavior on devices. In this demo, we are generating a quick report to get the feeder load sampled every 5 minutes for a particular substation. Our trend tool also allows to create quick trends to visualize past behavior for equipment. In this case, I'm adding a new trend for a motor. And I'm also adding all of the critical measurements that I need to analyze. Next, I would like to show you the ETAP Situational Intelligence product. ESI is the intelligence behind the ETAP SCADA solution, whether a site is a new greenfield implementation or is already in operation. ETAP SI brings the SCADA to the next level by bringing new information not offered on a typical SCADA. Situational intelligence will continuously scan the operating state of the system by integrating with ETAP power system monitoring. It will predict and identify areas before the operator takes any action. These insights will help the operator confidence to take actions because we already know how the system will behave. Additionally, ESI can provide unique insights about your system, highlighting the problem equipment and areas of the network which could benefit from maintenance and upgrades. This product is a multi-product integration aimed to provide a continuous system evaluation and provide a simplified and easy-to-read analysis. The heart of the situational intelligence product is the ETAP digital twin, which is the digital representation of the electrical equipment in the field. State and load estimation is used to analyze and estimate real-time operating conditions throughout the entire system. Using predictive simulation feature, we identify each electrical analysis that will need to be evaluated. For example, we can use load flow to continuously evaluate a sudden increase of load, or strength and stability to continuously evaluate the system response against the start of a very large motor. Scheduled scenarios are used to list all predictive simulations that will be running continuously. These scheduled scenarios will continuously run each configured predictive simulation to proactively identify how the system will behave if certain events or action will occur. Finally, the results are displayed and accessed using ETAP Web HMI client, making it easy to visualize system response before any action is taken. Note that these visualizations are provided in a way that operators can easily read and identify the effects of certain events of the system without detailed engineering analysis. Now let's take a look at this demo. This digital twin model is already enhanced by adding meters to reflect all locations where live measurements are available. As soon as I'm online, you can see the state estimation feature using the digital twin model and live measurements to continuously predict the power flow across the rest of the model. State estimation also creates additional notifications in areas where the estimated power flow is operating significantly outside the nominal range. This intelligence alarm considers the digital twin model and live measurements to provide insights on the health of the operation. This is a very unique feature not available on a typical SCADA system. Now, I will go to the simulator mode and create a scenario. I predefine a scenario to isolate a critical transformer. This section is where I will define all of the critical scenarios that will require to be evaluated continuously. Then, using the ETAP web client, all scenarios are added and configured to run periodically. Here, they are running every 3 minutes against real-time data. After this setup, my ETAP web clients can now visualize the results for all scenarios configured. Web clients are presented to operators so they can easily evaluate the results of all predefined predictive simulations originally created by the electrical engineer without requiring detailed analysis. Using situational intelligence, web client users are presented with a high-level summary of the results, indicating the health of the electrical system. They can also pre-validate the system response to an action to be performed. In this demo, we can observe the view of the ETAP web clients. For each predictive simulation schedule, I will navigate to my alerts section. You can see which scenarios will lead to alerts. For example, here the isolation of transformer T47 has no alerts, but if I start a large crusher motor, I will have critical alerts. And here if I isolate transformer T67, I will have marginal alerts. With this information, it is clear to the operator that they should not perform certain actions without consulting an engineer to make sure that the system is going to behave correctly. In conclusion, ETAP PSMS offers many benefits not found on a typical SCADA. The continuous evolution of the digital twin allows to improve model accuracy and reduce validation time. This also makes it easier to debug the electrical system. The integration of the digital twin and SCADA solution under one platform makes the deployment of simple but powerful HMIs for operators using state-of-the-art tools like SCADA Integrator. The ability to predict and resolve cost of operation problems helps to increase the reliability since engineers have a better insights about the behavior and response of the electrical system using real-time or historical conditions. And finally, the integration of tools like situational intelligence help to improve the system confidence for operators to make decisions with better confidence, understanding the potential response of the system to any action they take.